Every time you create a pod, the Kubernetes API server stores it in etcd with an empty node name field. At this point, the pod exists, but it isn't running anywhere. The Kubernetes Scheduler continuously watches for these unscheduled pods and tries to find a suitable node for each one. The scheduler doesn't immediately pick a machine. Instead, it runs the pod through a scheduling framework composed of multiple stages. The first major stage is filtering, sometimes called the predicate phase. During filtering, Kubernetes eliminates nodes that cannot run the pod. A node might not have enough CPU or memory according to the pod's resource requests. The node may not match the pod's node selector or node affinity rules. The pod might not tolerate a taint applied to the node. Or scheduling the pod there could violate topology, spread constraints. After filtering, Kubernetes is left with a set of feasible nodes. If the set is empty, the pod remains in the pending state and the scheduler will retry later. If there are feasible nodes, the scheduler moves to the scoring phase. Scoring is where Kubernetes decides which feasible node is the best one. Multiple scoring plugins assign points to each node. Some plugins prefer nodes with lower resource utilization to spread workloads evenly. Others try to pack pods together to improve resource efficiency. Affinity and anti-affinity preferences also contribute to the final score. The scores from all plugins are combined into a final number for each node. The node with the highest score becomes the winner. At this point, the scheduler doesn't actually start the pod. It performs a binding operation by updating the pod's node name field in the API server. Once the pod is bound, the kubelet running on that node notices that a pod has been assigned to it. The kubelet then pulls container images if necessary, creates the containers through the container runtime, and finally starts the pod. Modern Kubernetes scheduling goes even further with features like preemption. If a high-priority pod cannot be scheduled, the scheduler may evict lower-priority pods to make room. The scheduler also supports custom plugins, allowing organizations to implement their own placement policies. The important idea is that Kubernetes scheduling isn't simply finding an empty machine. It's a constraint-solving and optimization problem. Every pod placement is the result of filtering, scoring, and policy decisions that balance resource usage, availability, and application requirements across the entire cluster.